Hi there, and welcome to what is now the very last video in Foundations for Calculus 10. I'm getting better at saying that. The first section, which is factors of whole numbers. So in the last video, there was an explanation of how to simplify radicals using prime factorization, because it's the easiest way and it works all the time. And now I just want to do this assignment. It's part, there's an answer key, but I'm a fan of practice. It's as simple as that. So here we go. So the trick with these is simply start with treeing them out. That's to me why prime factorization, treeing stuff out is so powerful. All right, so 27 is where I'm going to start. I want to square root of 27. So I need to figure out what two numbers multiplied together give me 27. Now, if I'm having a brain fart or I'm tired, there's always a way. Somewhere you should have a list of prime numbers. 2, 3, 5, 7, 11, something, 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 13, 17, something like that. Formula sheet, midterm, probably even final. I would write that first thing because it's just easy. So all you need to do is you start with 27, and if you don't know what divides evenly, you go 27 divided by 2. That's the first number on that prime number list, equals 13.5. That's not a factor. For it to be a factor, it's always got to be a whole number. So we go 27 divided by 3. Okay, 3, 9. Actually, before I get started, so this is my prime factors: 2, 3, 5, 7, 11, 13, 17, 19, 23, 24, no, 25, no, 26, no, 27, no, 22, 29. And I'm thinking that's probably enough. Most of the time, you're going to find something, in this first little bit. So anyway, 27 divided by 3 gives me 9. So 3 and 9. Break down. 3 is prime. Break this one. 3 and 3. Okay, so the rule is when you're doing when you are simplifying radicals, use circle of pairs. Oh, and if you're worried, I could have circled those two also. Meh, whatever. And 1 from the pair goes to the outside. So this is this one. And the leftover is the uncircled one to the root sign. So 1 from the pair. And these are the leftovers. Not circled. And this one, in a way, kind of sucks because it's 3s, and without the explanation, it doesn't make any sense. All right, let's try it again. I'm going to fess up. I'm going to be lazy. I could go 2 and 24 and 2 and 12 and 2 and I'm going to try 6 and 8 because 6 times 8 is 48. Save myself some room. 3 and 2, 4 and 2, 3 and 2, and 2 and 2 and 2. You know what? It's messy. I don't know. I just don't like it. So I'm going to go. You don't have to do this step. One, 1, 2, 3, 4. 1, 2, 3, 4, 1. Okay, I just recopied it in order. It makes me happy. So this 2 times 2 is 4, times 2 is 8, times 2 is 16, and I'm just going to double check. 16 times 3 better be 48. Yep. Okay. It's just prettier now. I'm going to circle my pairs. Pair there. There's a pair there. And 3's left over. So 2 times 2 and the leftovers. And then we simplify. On this one, there was nothing to simplify. So 2 times 2 is 4. Root 3. Ta-da! A trick that Mark showed me. is if you want to check if you're right and you're just, all nervous, what you can do is you can go take the square root of 48. So on my calculator, I get about 6.9. I know there's other decimals, but it doesn't matter. And then what I can do, I'm not sure if this can work on my calculator. 4 square root 3 equals. Aha! Look at that. Look, 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 look. 6.9. It's exactly the same number. So why am I excited? Well, that proves that these two values, I've converted them both to decimals, are the same. This will help you in case you get which ones go to the outside, which ones stay behind. Because if you do 3, now I'm not writing this down. Sorry about that. Don't write this down. But if I did it the other way and I went 3 square root 4, I get just plain old 6. I don't. So if I had those backwards, right? See, accidentally flip them, I catch myself. So I would catch the error, and I like that. So that's one way to check. I also think it's a really good test question at some point. Okay, anyway, I digress. Let's do this. 4 and 2, 2 and 2 and 2. There we go. There's my pair. So 8 is cool. It's 2 square root 2. I'm going to do one more, and then I'm going to send you on your merry way and tell you to do this on your own, and then double check. 36. 6 times 6. 3 times 2. 3 times 2. You know what? I don't like that. Runs being that way. I'm just taking my factors, putting them all pretty in order. Now when I circle, it's not so messy. So there's a 2. And there's a 3. And there's nothing circled. So my answer is just 6. There's no root sign left over, which you probably know because the square root of 36 is 6. Done. No square root number, nothing. Done. Okay, stop the video. Please. Don't make me beg. Please stop the video and do them on your own. Okay, I'm going to trust that you did that for me. And I'm going to whip through these because it is Friday at 3:30 and I suspect people are going to keep opening the door going, aren't you going home yet? How about now? So it's also like minus 40 with a wind chill. Anyway, 32, that's 8 times 4, 2 times 4, 2 times 2, 2, 2, 2, 2 comes down, 2 comes down. So that is, there we go, there's a pair. There's a pair and a leftover 2. So 2 times 2, root 2. 2 times 2 is 4, root 2. And we're golden. There we go. All right, square root 24. I was trying to make this pretty, but I can't really. So 3 times 2 times 2 times 2. I'm getting lazy. I don't feel like rewriting it because it's kind of organized for me. There's my pair. And if you're stressing, I could have chose those 2's instead. It doesn't make any difference as long as I pick them. So 2 goes to the outside, leftovers 3 times 2. See, it's whether it's leftovers, or sorry, whether it's 2 numbers out front, multiply together. It's 2 numbers. Are you yelling at me? There. Right, because there's 3 and 2 left over. 2 square root 6. By the way, one sec. It's weird. If I had, right, 2 square root 3 times 3, this is the wrong answer, so don't copy it. That would have given me 2 square root 9. And I would look at that and go, that's ridiculous because the square root of 9 is 3 and that shouldn't be under root sign. Done. All right, 8 times, yeah, 8 times 10, that'll work. 2 and 4, 2 and 5, and a 2, and a 2, and a 2, and another 2, and a 5. And now we have a pair, and a pair. So one from the first pair, one from the second pair. So it's going to be 4, 5. If you're going, why are there so many numbers that 2s and 3s? It's because if you don't use 2s and 3s, the numbers get ridiculously big. And I just noticed something. That's the same as question 1. I use software to generate these, and sometimes they do that. Excuse me. So this is 3 times 25. Right. You could also do 5 times 15, but my brain thinks in terms of money. 3/4 is 75 cents. Is my pair. 3. That's going to give me 5 to the outside, 1 from the pair. Leftovers go there. Woohoo. Yeah. 18 times 10. I was trying to think of numbers that make it faster, but it doesn't matter. Any set will do. And if you're having a day where it's like I'm dividing it by 2 and I'm just going to keep dividing by 2, that's fine. Don't care. Still going to get the same set at the end. 6 and 3, 2 and 2. Whoa. 2 and 5. So if you've ever wondered why I'm always bugging students to learn their multiplication tables, this is why. You're not having to look this up. 2 and 3, and 3, and 2, and 5. Okay, that's, no, don't like it. Then put it in order. 2, and a 2, and a 3, and a 3, and a 5. Make the little dots. It's multiplication. And 1, 2, okay, 1, 2, 3, 4, 5 numbers. 1, 2, 3, 4, 5 numbers. I think I'm fine. There's a beautiful set of 2s and a set of 3s. So 2 times 3, left over 5, 6. All right. Oh, hello. That is a really big number. Oh, how mean of me to put that at the very bottom of the page. Sorry. Okay. 2, 4, 4, 8. I know it's divisible by 2, but I don't have enough room to make that work. I'm going to try 64 just for fun. Nope. 2, 4, 4, 8. I could go through my primes, but again, it's going to be messy and I want something big. 36. Oh, no, that's not it. 2, 4, 4, 8. 5 by 36. Oh, there we go. That was pretty odd. Okay. Why did I pick 36? I don't know. It was just a big number. It had some 2s and 3s in it, so we'll see how this goes. 6 and 6. Now, 68 divide by 2. 2 times 34. I did not know that. 3 and 2. And the other 6 is going to be 3 and 2. Bring down my 2. And 2 and 17. Now, that got significantly messy. So let's clean that up. There's 1, 2, 3, 4 2s. So 1, 2, 3, 4 2s. And there's a couple of 3s. And then there's a 17. There's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. You'd be amazed how many students lose a number along the way. It didn't take that long to count. So don't screw up. All right, pair, leftovers. So 2 times 2 times 3, 17. So 2 times 2 is 4, times 3 is 12. 17. And the last one, 432. Cube. Again, I don't want to divide by 2. I know it's going to work. I'm going to try 16. Oh, 16 times 27. Alrighty. 4 and 4. 9. 2, 2, 2, 2, 3, 3, and 3. So 1 pair, 2 pair, another pair. There we go. 2 times 2 times 3 root 3 left over. So 2 times 2 is, oh yeah, it's 12 again. 12 square root 3. All right. So for anybody that's stressing or worried that sometimes I was putting dots in between, sometimes I wasn't. If I was doing this to hand into Jody, my boss, oh, the paper, or to my teacher or something, I probably would go back and put the dots in between. It's not a huge thing. I don't even care if you do it, but just know it is multiplication, so they're there. But I just apologize because I realized some of them I did and some of them I didn't. But that's it. That's the end. Have a spectacular day. Stay warm, unless it's summer, in which case, stay cool. Hmm.